Hey guys, so I noticed that we all kind of struggled with yesterday's, or actually Thursday's lesson of rate of change and finding the slope from graphs and from tables. So I thought that a video of me going through the notes and the answer key would help you rather than just looking at the work with no explanation behind it. So let's just talk about the idea of rate of change. So rate of change can be expressed in many different ways. And I gave you this chart here to kind of help you see all the different versions of it. So when we're working from tables, okay, we like to talk about the idea as change in y over change in x, right? And we can express that using this little triangle that we called delta. Okay, delta y is just the change in y, all right? And delta x is just the change in x. So that's all that little triangle means. And from a table, okay, the way that we identify our x and our y values is that our x is always going to be our independent variable, and our y is always our dependent variable. All right, so in tables, we want to look at the situations, right? So x, or our independent variable, is always going to be our time. So for number 1, all right, our x is going to be hours. And that means that fences is going to be our y. So in words, that just means that the number of fences painted depends on the hours that we worked. All right. And in order to find the rate of change of the situation, we want to use the change in y over the change in x. So let's go down this y column and look at how our y is changing. All right. Each time, the number of fences goes up by 1. So our change in y is plus 1. All right, let's look at our x column. All right, if we go down this x, or the hours, let's look at the change in values. From 3 to 6 is plus 3. 6 to 9 is plus 3. And 9 to 12 is plus 3. So my change in x is plus 3. Now, I want to write my rate of change, or my m, as a fraction. So m, again, is equal to delta y over delta x, which is just change in. We said that our change in y over here was plus 1. So I'm going to put that value in for my change in y. We said that our change in x was plus 3. So I'm going to put that value in for the change in x. And I cannot simplify 1 over 3. Okay, we always want to express our rate of change fraction in simplest form. 1 over 3 is simplified. Okay, but now in this situation, we have actual variables that we want to write in. Okay, because this 1 and this 3 means something, right? 1 is our y value, which stands for fences. So I am painting 1 fence. Every 3, my x value was hours. All right, so 1 fence every 3 hours. We want to make sure that you guys include values when they're given. Okay, let's try another one. All right, now we're talking about miles per hour. So again, our x is going to be our independent variable, and our y is going to be our dependent variable. I said that the independent variable is always going to be the time. So again, my x is going to be in hours. My y is now the number of miles. So in words, miles depends on the number of hours. All right, and we want to find that rate of change. So we want to find our change in y and our change in x. So let's go down this y column. My y is changing plus 70 every time, right? From 70 to 140, from 140 to 210, from 210 to 280 is plus 70 every time. Feel free to use a calculator if you guys need it. Okay, now if I go down this x column, my x is changing plus 2 every time, from 2 to 4, from 4 to 6, from 6 to 8. All right, so my change in x is positive 2. So if I want to express this as a fraction for my rate of change, I'm putting the change in y over the change in x, which is 70. My change in y was 70 over positive 2. My change in x was positive 2 over here. So now, I told you in the last problem, we want to make sure we simplify if we can. So 70 over 2 can be simplified. If I divide top and bottom by 2, that gives me 35 over 1. Okay, now that my fraction is simplified, I want to make sure I include my variables that the problem gave me. So my y value was miles, so I'm going 35 miles for every 1 hour. All right, and we want to make sure that you guys include those in your answers, all right, because that gives meaning to the problem. All right, let's try one more of these. Okay, so now, again, my independent variable is my x, which is time, and now my y variable is my dependent variable, which is elevation or feet. So my elevation for this hang glider is dependent on the amount of time, okay? So if I go down this y column, let's look at the change in y. Okay, from 360 to 325, looks like it's minus 35. Okay. From 325 to 290 is minus 35 again. And from 290 to 255 is minus 35 again. So my change in y is minus 35. Look over at my change in x. Okay, this one's a little bit easier. My change in x is plus 1 every time, from 1 to 2, 2 to 3, 3 to 4. All right, so now if I want to express this as a fraction, I put my change in y over my change in x. Now, the negative here matters, okay? I'm going down 35 every time, so I want to include that in my rate of change. It's minus 35 over positive 1. All right, so now my fraction is simplified, and I just want to make sure that I include my variables that I'm given. So my y value was elevation, so it's minus 35 feet for every 1 minute. All right, and that's my final answer. All right, now let's do a couple more examples where we're not given units, okay? So this table just gives you the x and it just gives you the y, okay? We don't really need to include units like feet or minutes or miles or hours because we're not given any. So we just want to find our rate of change or our change in y over our change in x. All right, so again, we go down our table. It looks like my y from 10 to 5 is minus 5, from 5 to 0, minus 5, and so on. All right, so that change in y is minus 5. If I go down this x column, from negative 2 to 0, positive 2, from 0 to 2, positive 2, 2 to 4, positive 2, 4 to 6, positive 2. Okay, it's a constant rate of change. So now, when I go to write my slope, or my m, all right, we said it was change in y over change in x. So my change in y is negative 5. My change in x is positive 2. So my slope, or my rate of change, is negative 5 over 2. Now, that can't be simplified any further, and there are no units that I need to attach. So that is my final answer. All right, we're going to look at 2 more tables before we go to graphs. Okay, now when we, again, go through our table here, no units, just my x and my y. So I go right down my y column. Now here, we notice that there really is no change in y. From 6 to 6 is plus 0, plus 0, plus 0, plus 0. Okay, that's okay, it's constant. Y isn't changing, we're just adding 0 every time. Now, if I go down this x column, -2 or -4 to -2 is +2. Hold on, pen's not working. Here we go. +2, +2, +2, +2. Okay, so now when we go to put this into our slope, change in y over change in x, you notice our change in y was 0 over change in x was +2. Okay, now this is a situation where if I have 0 in the numerator, okay, if you were to type this into your calculator, 0 divided by 2, it would give you the final answer of 0. All right, and like we talked about yesterday, okay, on a graph, a slope of 0 would be a horizontal line. All right, and that is possible, okay? We can have 0 divided by a number. Your calculator will output you 0. So my slope or my rate of change here is 0. And again, on a graph, it would just look like a horizontal line. All right, now if we look at number 6, notice, okay, that our change in x is 0, right? It's just 5 every time. It's not changing. +0, +0, +0. Okay, my change in y this time is +2. So when I plug that into my change in y over my change in x, okay, I have 2 over 0 now. So notice that 0 is now in my denominator because it was my change in x. All right, if you were to type that into your calculator, it would output you as an error. All right, so whenever you have a 0 in the denominator, all right, that is called an undefined slope. All right, and just like from our graphs yesterday, that would be a vertical line. All right, so if you ever find that your change in x or your denominator is 0 and your calculator outputs an error, your slope is considered undefined, and that's what you write as your answer. All right, if you have 0 in the numerator, all right, 0 divided by 2 would give you 0 in the calculator, and that is a slope of 0. So that's the difference between a 0 and an undefined slope from a table. Okay, now let's move on to the graphs. Okay, so again, from a graph, okay, we find our slope using the idea of rise over run. All right, so we want to count from point to point, how many up, how many over, how many down, how many over. All right, and just to give you guys an idea, all right, if we go left to right on our graph and our line is increasing, it is a positive slope. All right, if it's decreasing from left to right, it's a negative slope. Like we talked about in the last two problems, all right, a horizontal line has a slope of 0, and an undefined slope is a vertical line. All right, so just use those as you go through to do some of these practice problems. All right, so let's find the slope of these 3 problems here. Okay, so I always like to start left to right. All right, so if I start at this point here in red and I want to count my rise over run to the next point, okay, I have to go down 1. So my rise is -1. And then I have to go right 1, 2, 3, 4. Okay, so my run is going to be +4. And I'm just showing you that on the graph there. So my slope is going to be -1 over 4. If you guys chose, and I'll do this in purple, to start at this right point, okay, and you wanted to work from right to left, in that case, your rise would be +1. All right, so it's 1 over, and then you have to go left 4 to get to that second point. So your run in that case would be -4. Either way, notice that you get the same answer, okay? Either way. In the first situation, your rise was negative, so it's -1 over +4. In the second situation, your run was negative, so it was +1 over -4. All right, let's try one more together because my time's about to run out here. Okay, so for this, I'm going to start at the leftmost point. I have to go up 1, 2, 3. So my rise is +3 over my run, which is 1, 2, 3, 4, 5. over